So let's get started. So first, a very quick introduction. I am Dr. Young from the physics department, and I am a computational condensed matter physicist and also an AI enthusiast. So I want to combine physics ideas and computer science ideas and use them to do interesting things. In particular, I study what I call dancing electrons in bilayer Moire materials. So you probably have heard of graphene. It's a very thin sheet of material that's just one layer of carbon atoms, like so, and that's called a two-dimensional material. But if you take two of those two-dimensional materials, stack them on top of each other, and slightly detune them a bit, they will form long wavelength interference pattern like this, and this is called a Moire pattern. This is very much like musical beats. If you ever played music, if you play two tunes that's slightly out of tune, then you will hear this long temporal wavelength interference pattern called a beat, and it sounds like wom, wom, wom. You guys heard about that? The individual sounds that you're making have very high frequency, but the beating pattern have very low frequency. When we play music in time, we want to dance with the music. It turns out if you create this Moire pattern, which is the beats in space, electrons want to dance along this music. And that's what I want to learn. So as a physicist, I write down a quantum wave function for the electrons, and it will involve a bunch of parameters, alpha, beta, gamma, whatever. And I tweak those parameters to see what the electrons want to do, what do they like best. So how does AI come into all of this? Well, we can incorporate AI into these wave functions by squeezing a neural network into the wave function rather than putting in just a number of variables. And now this is a wave function with hundreds of thousands or millions of parameters, and it's able to capture the electron dances to much higher accuracy. So this is one of the examples of the electron dances that we've been able to find. You'll see three electrons holding hands. Not only do they hold hands, they spin together in the same direction. So the red means that they're spinning in the same direction. The blue means they're spinning in the opposite direction. So you get these triplets of electrons that line up on this regular pattern and they dance together. So that's kind of what I do. The reason I'm talking to you today is that in order to do any of this stuff, you really need to learn about how to use computers best, how to use computers to do data analysis, how to use computer to implement the AI into your wave function or whatever other function you want to study so that you can do work. Okay, that's why I want to introduce to you today how to use Python and Jupyter Lab to do all of these things. So why do we want to learn Python? Probably a lot of you already know Python or have heard of it. It's basically the workhorse of data science and AI work. Most people who do data science and AI knows Python. It's also extremely simple language. It's extremely readable, meaning that it's easy to learn, and it's easy for people who don't even know it to understand what you wrote. So that allows collaboration across discipline, which is a focus of what we want to do. In particular, for data science and AI, Python is great for one big reason. That is, so many people use Python. There's a huge community. So if there's something that you want to do, somebody probably have already done it. So all you have to do is take what they have already done and use it in your own research. And the things that people have already done are called packages. You have to install those packages, and then you can do the things very quickly yourself. Okay. Python is also a great glue amongst other languages. I actually made a presentation when I was in graduate school about how to use Python to glue together C++ and Fortran code. You'll probably know that C++ and Fortran can run very fast. They're like big muscles. But then Python is the smart brain that allows you to coordinate those big arms and swing them in the right direction. So if this doesn't scream smart brain to you, I don't know what does. So if you're interested, you can look over the slides I made back then to take a look. All of these will be posted on YouTube in probably a week or two. But yeah. Okay, so in addition to Python, I also want to talk to you about Jupyter Lab. Jupyter Lab is actually a great environment in which to learn Python. So what it is here's a screenshot of Jupyter Lab shown on the right, and you can see it's a lot of things all combined into one. So you have a file browser, which will allow you to look at what files you have, create new files, open them, edit them, whatever you want. It has a programming environment, so you can type in Python code and then run it to generate results. And you can also keep the results in here. And so if you keep all your results in the same file, that can serve as a lab notebook. So everything is in one place. And moreover, you can use it as an editor to edit text file. You can use it as an image browser to show images. It's just a whole lot of things all rolled into one. So I find it extremely useful for prototyping code when you want to do things fast and you want to see the results immediately. And to iterate, Jupyter Lab is the tool of my choice. So some pro tip about how to use Jupyter Lab. You can hold Shift and Enter to execute a cell. And if you notice on your keyboard, the right shift is right below the Enter key. So you can just go Shift, Enter, and then it will execute the whole thing very, very quickly. And we'll try that in a little bit. It's also able to keep markdown texts in addition to Python code. So you'll see there's a foldable tab that says open something panda something. You can basically write down notes alongside of all your data and a lab analysis such that everything is in one place. So it's also a great place to keep a lab notebook. Yeah. And for today's purposes, I think this feature is the most useful. It's able to give you the help function, the help string for any function that you want to learn about. So if you have an unknown function that somebody made, so this is a package, sklearn, and it has a function called make classification. And if you don't know how to use this function, you can just click into the parentheses and hold Shift and Tab. So on your left-hand side, Shift and Tab are right on top of each other. So if you hold those two keys, it will bring up this very helpful string that tells you what inputs the function expects. So I think this is a great environment for learning Python for the first time. Question?
Just the obligatory dumb question of the day. The website you're talking about is the same one that you had us get the usernames and passwords for on the sheet.
Yes, it's OOD. Yeah, so open on demand. Okay, for sure. Yeah, of course. So maybe I show you this. Just do ood.star.hofstra.edu, and you should see this screen. I see. Yes. So you should. So actually, I have a different type of account. So I'll sign in over here, and then if you want to follow along, you need to open the Jupyter Lab. Oh boy. Yeah. So Jupyter Lab is this. If you click on the Jupyter Lab, you can select an account. Well, I guess you probably have some sort of default account, and then just make a normal queue, use 1 CPU, 0 GPU, we don't need any GPU, and request 1 hour, and then press launch. This will help launch a Jupyter Lab notebook. It takes a little bit to start. Yeah.
I'm a little confused. Like, what is the purpose of a password and the username? Like, what are we what are we going to be interacting with here?
We are going to be learning Python using a Jupyter Lab. So the username and password allows you to log into the computer that has everything installed. Yes. Uh-oh, okay, so somebody will help you with that. Okay, but let me just continue. We'll help you with the technical questions in a bit. But just to tell you what you would do when you first get to Python, as I said, the main strength of Python is the availability of packages. So the question is, how do you get those packages? And the answer to that is use the Python package index. And they have a program called pip, PIP, that allows you to install packages. But there are sometimes version collisions within Python. Like I'll use Python 3.9. I have a few packages with version 2.1 or 3.2 and then run everything with those versions. If you upgrade, everything will break. So how do we keep our projects rolling even when all the rest of the packages get upgraded, right? We don't want to deal with those. So the solution to that is create your own virtual environment. And this is the command to create your own virtual environment, Python 3-m vm, create a virtual environment, and then you give it a location. So a virtual environment is just a folder with all your files, and you can decide to put it wherever you want. I'd like to put it under the .vm folder, but you can decide on wherever you want to put it. And then once you have created this virtual environment, you can source this activate thing to activate the virtual environment. You can see the DSAI virtual environment is now active, and then you can use pip to install these packages with specific versions into your virtual environment. So you have full control over this virtual environment. You can decide on exactly what version of package you're going to use so that things are not going to break unexpectedly. Okay. So I recommend that you can make an alias to activate whatever environment. So like, for example, I'll have whoops. Oh, yeah. So this alias, I say my Python environment is source this DSAI environment. You can change this PyInf into anything you want. Maybe call this DSAI PyInf, call this computer science PyInf, call this physics PyInf. And next time when you need to activate it, all you have to type is PyInf and you will activate this environment. So that's just something I like to do. One thing I think is very helpful to understand, just as a frame of mind, is that this virtual environment is just a folder. It has a folder. Inside that folder has all the Python packages. Each Python package is just a folder. So you can move those things around. You can copy and paste them. You can delete them, just like you do any other folder. So with that out of the way, there are other tools that helps you interact with these folders very efficiently. Yes?
No. Actually, no, I need more time to think.
Okay, sure. Yeah, come back. I'll come back to you. So once you created your virtual environment for your Python, actually a thing that tends to be a stumbling block for a lot of people when they get started is how do I then use this virtual environment inside of my Jupyter lab? So Jupyter lab is a lab, and then it can use any Python version, but how can I make sure that it uses my Python version? Okay, so the way you do this is to create a so-called custom kernel. And this custom kernel is just a file that you put in the specific location. So this is the location Jupyter will go and look for custom kernel. It's .local share Jupyter kernels DSAI. Jupyter kernels, that's where it will look. And then you can put whatever custom thing you want. So for example, here I want to put my DSAI kernel here. Then I just create a folder called DSAI and then make a file called kernel.json. Then within this file, all you have to provide is where is your virtual environment. So you see, this is the main line that matters. Where is the Python in your virtual environment? So I just give the path to the Python of my virtual environment. You can see it's the DSAI virtual environment that I just created. And then the rest is just boilerplate. So you put this in and then put this file there. Jupyter will realize that, this is a custom kernel that I can use, and I will use the user's Python. So you want to edit this file. I don't know how many of you are familiar with editors. Question.
Yes. So does that mean that each Jupyter notebook has their own kernel? And can a Jupyter notebook have multiple kernels?
Yes, it can. So you can open multiple Jupyter notebooks, each with a different kernel, all within the same session. That's totally possible. So it's very flexible. You can even open the Python kernel, open the R kernel, open the MATLAB kernel, all in one session. So it's very powerful in that way. Great. Okay, so that's the basic setup. I think it's probably a good time to take a pause and have everybody make these setups, and I'll come around to help you before I get to actually running the Python code. Okay. All right, so once you have the environment active, you can install whatever package you want into it. So we're gonna install some of these packages. In here I said I was putting specific versions, but actually most of the time that's not necessary because if the packages are well developed, they would all be compatible with each other at the newest version. So you can just type, we need Jupyter, we need matplotlib, we need pandas, we need Seaborn, we need stats models. And I think that's about it. Here's the problem. The default Python on the computer is 3.9, which is too low. We need a higher version of Python. So what you need to do is module load Python, and then we'll load in the newer version of Python. And unfortunately, we have to delete the entire environment and start from scratch. Sorry about that. So you just have to go here to get it. So what I would do, the command would be copy this file into your home folder. So like that. And you should be able to get that file.
Change it up,
And then
and then
you enter edit mode by typing I, and then you can delete this and typing my username. Or nano. Yeah. Okay, you know what? I think, unfortunately, this part didn't go as well as I wanted to. So there will be some things in my example that you can run, but let's just power through and run the simple stuff that we can all run without the virtual environment, okay? So all you have to do is do copy-R. I have some example files set up for you. Go back to the shared folder. It's under projects, DSAI, 02. Just copy this entire folder into your home folder. So please do this. All right, so do we all have the folder? So if you have the folder, so once you have the folder, you should be able to open it up in Jupyter Lab. So go back to Jupyter Lab, and this folder should now exist. And you can, there is a Jupyter file in here called Jupyter time series. And please open that up. And this is actually the main meat I wanted to get to. I didn't realize the technical thing was gonna be such a disaster. A very quick introduction to what Python does. It's a programming language that's actually very easy to read. You can create variables in Python, which is just containers for whatever you want. So here I can have A is a word hello, B is a word world, C is a number 3. And you can define these things, and you can manipulate your variables. You can add them. So A plus B will be hello world. A plus B times C will be 3 times hello world. So you will say it 3 times. So you can follow along by just holding shift and pressing the enter on your computer. So does that work for everybody?
does it say to run it easy?
Yeah.
Shift enter?
Yeah, just shift enter. It should just run it. And you can do your own edits, whatever you want to do. And you can just run it and it will give you different results. Does that work? Yeah, okay. So at least this part is working, thank goodness. All right, great. So here are how you define variables. And another basic object in Python is called a list. And the list is just a list of variables. So here I made a list that's A, B, and C. So you can see this list contains hello, world, and 3 altogether. You can add an item to the list by using the append function. And now the list will contain 3.0 in addition to the other elements. I can take the first element out from the list by saying I want the 0th element, and you can see it will return you hello. If I say I want the last element from the list, it will return you 3.0. Okay, so very, very simple. You can also do this slicing of a list. You can go from anywhere to anywhere by using the index. So if I want all but the first element, then I say start from, so ignore the 0th element, but give me everything else. So you can see it gives you world 3 and 3.0. It ignored hello, which is the first element. There's a funny thing where you can do a reverse. You can reverse the order of the list by splicing in the -1 direction. So I'm taking all the element of the list, but I'm going to go from the end to the beginning. So they're just little tricks that you'll learn. By the way, I wanted to mention before I forget that I took a lot of these from this book, which there's a website for it. So if there's something I didn't cover, you can go there and catch up yourself. Okay. And so once we've done all this, it's also a good idea to fold this to organize your notebook. So you can see these things are folded, cells are hidden, so the notebook doesn't get out of control. So I really like Python, the Jupyter notebook for that reason. Okay, the third object I wanted to introduce to you is the dictionary object, which allows you, it's kind of like a list, but instead of accessing elements by the numbering, 0, 1, 2, 3, you access elements by a name. So I'm going to name A as A, I'm going to name B as B, C as C, and that creates a dictionary like so. And I can also assign a new element to the dictionary. I'm just going to say D is 4, and if I do that, D will now contain 4 elements, and the last one is D is 4. If I want to take an element from the dictionary, instead of giving it an index 0, 1, 2, 3, I now give it a name, and that will retrieve the value from that dictionary item. I can ask, what are all the things available in this dictionary? And you can just say dictionary.keys, and this will return to you all the things that are available. I can loop through all the items in the dictionary. So I can loop through all the key and values in the dictionary by using the items function, and that allows you to print the key equals to value of every item that's stored in the dictionary. So dictionaries are very useful. It's a more flexible way to store things than list. It's also very fast to look up. Okay, so I kind of alluded to this a little bit, but you can create things, functions in Python that allows you to take variables as input and return something else in return. So the simplest function is probably just the add function. I'm going to give it A and B, and it's just going to add them together. So given that we have the A and B, you call the add function on there, you just get the result of A plus B. You can see it's the same result if you just add them, because the function, all it does is just execute whatever you define within the function. Now I can define a new function that combines A and B and C. And you can see it does exactly what you want the function to do. So defining functions to do complicated tasks is one of the simplest ways to make Python extremely powerful. You can define a few functions, put them away, and then you can use those functions in very creative ways to build complicated programs. Okay. So here I have a somewhat more complicated function. I say I always want to take A, B, and C as inputs, but then I'll ask what I can do to those. So if I want to add them, then I'll just add A and B. If I want to combine them, then I will call the combine function in A, B, and C. Otherwise, I don't know what to do, so I'll throw an error. So here you can see the default behavior is to add A and B, so that's the result. If I tell it to combine them, it will call the second function. But if I tell it to multiply, well, I don't know how to do that, so it just throws an error. But Python is very graceful when the error is out. It's a very simple error message. You can see exactly which line in the code is causing the error and why. So Python is also very nice in the sense it's easy to debug. Okay, last but not least, there is a concept of classes in Python, and all it does is just a way to organize all your variables and functions. So here, when you initialize a class, you can put whatever things, the ABC, inside the class, and that will encapsulate them so that they can be retrieved later through the class. I can also make a call signature to the class, and that just calls our most complicated function. So you notice I stored a mode for the class, which I allow the user to set. What this is nice is that you can define here what the class is able to do, so that when you try to set the mode of the class, it will tell you, this mode of operation doesn't exist. I can error out before I even go to call this function. Okay, so here I'm going to initialize this class, cool stuff, using A, B, and C. And you can see the values are now being, the variables are now being, have now been encapsulated. I can access them by using class dot, whatever variable that I have stored. I can call the function, and it will call the default behavior, which is using the mode add on A and B. Then I can set the mode to combine. And now if I call the function again, you can see it's not adding A and B, but it's combining A, B, and C together. But if I try to set the mode to multiply, it says, I don't know how to do that. So it can gracefully exit without performing any work and tell you this is not something that I can do. Okay. You can also work with files within Python very easily. So suppose I write a text file. So there's a magic command in Jupyter Lab, this write file magic command that allows you to write a file with the following content. So you can see if when I execute this cell, it will write that file. And then we can open this file up in Python. So you just say open the file name, and I want to open it for reading. Then I can read the content of the file, and the content is just whatever we wrote to it. So it's pretty neat, pretty easy. And you can see that when you read a file, what you get in return is a text, is a string. It's a string that has all the content of the file. We can also read this file line by line instead of just reading the whole thing, because sometimes the file can be very long. You don't want to just store all that into memory. You can go through it line by line, like the genetic data that Kay presented last time. So you can go through it line by line, and it will return a list of lines, and you can loop through that list one line at a time. So you can see the return is a list, and you have these lines. In fact, you can go even further by saying, I'm going to open this example file as a file, and I'm just going to say for line in file. And this will go through one line at a time instead of having to store them all at once. And you can print the line, and you can, oops. And you can see it will just print one line at a time as it go and read the file. So this is probably the most memory efficient way to go through a file. Okay, so these are the basics of Python in a very, very short amount of time. There's a lot of depth to Python, and if you're interested, please go through this book. And there are also other very good resources out there for learning Python if you want to go into depth. Okay, so today all I want to show you is the basics and something interesting that we can do using packages that other people have built. So within the file that you downloaded, there is a air passengers dataset, the CSV file. One thing I wanted to say is that within Jupyter Lab, you can call bash. So it's possible to call bash directly from Jupyter Lab just by inserting this exclamation mark in front. And by using this, I can tell that this file exists. If the file didn't exist, this command would fail. So for example, if I were to say ls, I'm just going to take this and then misspell it a little bit, and it says the file is not there. So Jupyter Lab gives you direct access to the bash within its notebook format, so you can combine Python and bash code very easily. So now this is the part that's probably going to fail for you. I import all these packages. Oh, it fails for me too. Great. I'm going to pip install stats models. Okay, stats model is now being installed, and hopefully that works. And then I can now do this. Okay, so Pandas is a very fun package that allows you to read large CSV files, large data files, build it into a data frame so that you can manipulate the data however you want. So now what I'm doing here is just I read that file into a Pandas data frame, and that allows you to look at that file, what's in the file. Well, all it is just recording the number of passengers that fly on airplanes from 1949 until 1960. So that's what the data set is about. And we can do some light processing on the data because this month is a text, and texts are hard to work with on the computer. I want to turn that text into a number. So all I'm going to do, you see, I create a function to turn that text into a number. And this function will basically take the month and subtract the year from 1949. So this is the number of months that has elapsed since 1949. And you can test this very easily just by creating a test. And you can see air month of 1940, air month of 1949-01 is the month number 1. The second month is month number 2. 1955 is month 74. So you see within Jupyter Notebook, it's very easy to prototype your function, play with it, and if there's a bug, debug it. So now that I know my function works, I can deploy this function to convert all the months into some X that I want to plot. And the Y is just the number of passengers, and I can make a plot using matplotlib, and this is the data. Okay, so that's what the data looks like. So on the horizontal axis, you have the month since 1949, and on the y-axis, we have the number of people who have taken a flight. I personally find it easier to work with arrays. You can take pandas data frame columns and convert them to array like this, but you can just directly work with them. That also works. I just didn't want to retype df parentheses x every single time. So I save it into x, I save it into y so that it's easier to work with. So this is a time series data because it's some value as a function of time. And there are multiple ways to analyze time series data. For instance, the thing that you want to know, one thing you might want to know is what is the correlation of this segment of time with the next segment of time. This is called a autocorrelation because it's the correlation of the time series with itself with the time shift. But other people have implemented this function, so you can just call it. I don't have to implement autocorrelation myself. It's already there. You just call it. And this is the autocorrelation of the trace with itself. Okay. It looks kind of interesting. There might be some patterns, but it's not super clear what that pattern is. Well, there is actually a simple way to see that pattern more clearly. So what you see here is that this data is not stationary. It has a trend. It's trending upwards. It's much easier to analyze the data if you detrend it. One simple way to detrend the data is simply just to take a derivative, take a difference. So NumPy has a function that allows you to take a difference of the time series from one time instance to the next. And here's what I'm plotting. You can see this is more or less stationary. It's just oscillating around 0. And now if I plot the autocorrelation time, there is a clear signal that you're seeing. The clear signal is that every 12 months, there is a peak. And what that means is that if I want to know what the number of passengers is going to fly in today, the easiest way to predict that is to look at how many passengers were flying 12 months ago. And that tells you there is a seasonal cyclic behavior in this data with a period of 12 months. Okay, with that in mind, we can now use a seasonal decomposition from the stats model to calculate the trend of the data. And then the detrended data would be the raw data with the trend subtracted off. And you can easily plot them all together. The blue is the raw data. The orange is the trend that was calculated using stats model. You know, if you want to know how this is done, you go into the documentation of the people who made this. They did a lot of work, so we don't have to do it. And you can see this is the trend. If I subtract the trend from the raw data, I get this green line. And that is the detrended data. This detrended data is easy to analyze. Well, actually, first of all, the trend is easy to fix, to fit. We can fit the trend and plot what the trend is. This is the gray line is a fit to the trend. I just fitted a fourth order polynomial to the trend. And I'm showing you what that fourth order polynomial looks like in the gray dashed line. You can see I was able to fit this smooth trend very well, and I'm able to extrapolate it. And further, this stationary data is also not too hard to model. So all I have to do is I know this repeats every 12 months, and the fluctuation seems to increase as time goes on. So I'm just going to ask, what is the average fluctuation every year? How does that increase as a function as the years go on? And here's the data. The blue line is the data, and I can fit that to a polynomial. Okay, so this is probably a less accurate prediction, but it's a prediction nonetheless. Then I can make a prediction for how much the fluctuation will grow. I can also make a prediction for how much the trend will grow And by adding them together, I can make a prediction of what will happen to the number of passengers in the next 5 years. And you can see, I mean, I don't know if it's correct, but that looks pretty reasonable to me. So you can work with time series data, detrend it, fit the trend, fit the fluctuation, and then make your own predictions. Question?
Have access to this like later on today and maybe even like tomorrow or something, right? If you want to go back and look at it.
When will the accounts be deleted?
Yes. Yes.
Okay, thanks. Yeah. So it'll be available for a bit.
It's available on the accounts. Don't have to balance.
I'd like to know if I give them go back and look at it.
Yeah. Okay. Yeah. So I guess we're running out of time. So I just quickly show you this last bit where I downloaded some stock data. So you can go to Yahoo Finance and you can download the most recent stock data. So I started from the year 2019 and then downloaded all the data for 2 years. So that's about just right across the pandemic. And you can import this stocks data and you can look at it. So it'll tell you the date and how high the stock was, what was the high, what was the low, what was the closing price, and what was the company. So APPL is Apple. So here, what you can do is you can use Seaborn, which is another plotting package that builds on top of Matplotlib to visualize the stocks. And so here is what I just talked about autocorrelation, which is the correlation of a time series with itself. But this correlation, this pair plot, calculates the correlation between different time series. So the price of Apple stock as a function of time is one time series. The price of Microsoft stock as a function of time is another time series. There could be a correlation or decorrelation between those, and this program will calculate it. And so you can see here are the results. Oh gosh, this is too big. Can we make it a bit smaller? Well, maybe you can still kind of see this bottom bit. I think this is probably enough. So you can see Apple stock here is almost perfectly correlated with Microsoft stock. And it's somewhat correlated with JP Morgan stock, although JP Morgan kind of stayed flat during when the pandemic hit. And then this is United Airlines. You can see where the pandemic is and just goes boom. And by looking at this data, you can calculate the correlation across different stocks and make what's called a correlation matrix. So there's a heat map for the correlation matrix. And you can see each stock is perfectly correlated with itself. There's no surprise there. But Apple and Google and Microsoft have very high correlation. They rise and fall together. Whereas Apple and JP Morgan are not very correlated at all. The correlation is almost zero. Whereas Apple and United Airlines has a negative correlation. When Apple is going up, United Airlines is crashing through the floor. So you can use Python to look at these data, visualize big data sets, and make plots to get a quick understanding. Okay. Well, this is going across the pandemic. Yeah, so you can see what happened is they were going okay, and then the pandemic hit, and then there was a huge drop.
The one with itself, like this is with time, but because Apple.
No, actually, yeah, if you plot it with time, it's a bit different. So, oh gosh, I'm not gonna do it. If you do it as a function of time, you can see. Yeah, because you actually have to convert this date to a time. I didn't do that. So it's a few more steps, but you can see there are so many functions that other people have written. This is the power of Python. There's a huge community out there who are working on data science and AI using Python. They build very nice packages which we can just import and do very impressive stuff without writing any code ourselves. So that's the main message I want to get through to you. So I think it's very important to learn Python if you want to work in this space, because you can leverage all of the latest development from the entire community. So that is all I have. I will take any questions, and please help yourselves to more food.